perfect
Like any
angle
video
of video.
you recorded and you tried for that?
I mean, this is the perfect video. Like the camera angle is good for tracking the persons. So
Your
that's
voice is breaking actually.
And actually, this is the correct angle of the camera, ma'am, so that we can track the people easily. So that we choose this video, ma'am.
That is fine. So you could have also recorded, no, the angle.
Because ma'am, we are trying, ma'am, that one. Like that, we are extracting some of the store videos that will have the perfect angle for.
Can you show
tracking the
some other
people.
video?
Yes, ma'am. Okay, ma'am.
Okay.
Is it identifying?
Meenakshi, any questions from your end?
Like this video, they are not showing the boxes and
Ma'am,
not
this is-
recognizing the people.
I am just showing the demo that we need to have a perfect video angle to tracking the people, ma'am.
No, I
We
don't
just got this.
find anything. Like I'm not convinced
Aparna,
with
your
your
project is-
project output actually.
Correct.
Ma'am,
Not able to
I want
understand
to-
very clearly. See, what
Ma'am, I want
is
to say
your
that-
project is all about? The project is what? What is your project all about? What is the main
track the-
feature? What are the main features of your project? You please explain.
Ma'am, I am unable to listen, ma'am. Once.
Yeah, you're audible. So your project is all about AI-driven football analytics for game-changing insights, right? But the video is showing something else.
Hmm.
Ma'am, it is our project is about footfall analysis in the store, ma'am. Analyzing the footfall analysis.
And then
of
the
people.
students are not at all audible. Really, I don't know how much effort we can make from our
No,
end.
it's okay, but you are working on some video which is pre-recorded. How do we know that it is recognizing or the video was edited like that? If we can't experiment on the new video or we can't see on the live video, then how can I say that your project is actually working? If my project is working, that means I can upload any video. Okay, let's not identify all the people. At least few people it should identify. There is nothing like a perfect angle or something for the camera, as per my understanding.
And also, when you are, you need an application, right, to upload the video, do the analytics, and then display the result. But we are not, you are not showing us that thing. You're just running some codes in Jupyter Notebook and the downloaded videos which are in WhatsApp, you're just showing us. We are not understanding what is your final output. And you're taking, half an hour time. That is the issue now. And
Ma'am,
you're
for generation of the video, it takes so much of GPU, ma'am. So that we're generating video of the people.
But you should show us live demo. How do you upload? This is what we are seeing from past 100 presentations. You are not showing us.
It needs so much of GPU utilization, ma'am. By running this now, it will dragging
so much. I think Meenakshi, I cannot just waste time on this. Please, let's move, okay? Thank you so much. Forecasting trends with powerful LSTM models. Please load the PPT.
Man, give me one more 10 more minutes, ma'am. I will run in GPU, ma'am.
No, please. Already you have taken a lot of time. Please just see 1 hour over. We are still in your presentation only. We cannot take it. It's done. Your presentation is done. Thank you.
And actually, you are telling about GPU. You have used the pre-trained model, so actually you have to optimize it for the real-time use, the GPU acceleration and hardware setup.
Please upload next presentation. I request to share the PPT. Yeah, please unshare. Yeah.
Just a minute.
LSTM models are ready. Next team, please load the
Yes,
PPT.
ma'am.
Why are you taking so much time? Share the screen. Yeah. Start with the presentation.
Is it visible? Okay. Yes.
Good evening, ma'am. Good evening, everyone. I'm M. Sai Nikita. I have been working on LSTM forecasting models. I love next slide. These are the contents. Introduction. Time series forecasting refers to the process of predicting future values by analyzing historical data, making it an essential tool for decision making across industries. Importance in industries, weather forecasting, stock market, energy management. Objective. Investigate and implement various LSTM based models to improve accuracy in forecasting tasks with a focus on weather prediction.
Are we changing the slides? Yeah. You can directly go to the methodology, no? Yeah, next slide. Next. Yeah, start here. You need not go very detailed. We know all of this. You can directly go to your project methodology, what you have worked on. Yeah, start.
Dataset working the GNR climate dataset, which includes temperature, humidity, pressure, and wind speed. Data source. GNR climate data source is widely used open source weather dataset for machine learning applications. Key features. Temperature, humidity, pressure, the main variable for prediction. Humidity have significant indicators of weather patterns. Data splitting, training dataset and testing dataset. Training dataset, 80% of the dataset was allocated for training the model. Testing dataset, the remaining 20% was reverted for testing and evaluation. Visualizations. Heat map, line graphs. Heat map illustrate the relationships between futures to identify significant variables. And next milestones will continue my teammates.
So yeah, am I audible? Hello.
Yes,
Yeah,
you
you're audible for everyone. Please continue.
Okay. So in milestone 2, our goal was to predict future temperature values using univariate LSTM models. We explored various architecture to analyze their performance. Like we used vanilla LSTM, stack LSTM, bidirectional convolution, and CNN models. So vanilla LSTM, a single layered model that captured basic strength but struggled with seasonal patterns. The stack LSTM was it was improved accuracy by using multi-layer for non-layer dependencies. By using bidirectional LSTM, it enhanced the result by processing data in both forward and backward direction. The CNN LSTM combined CNN for spatial features and LSTM for sequential dependencies, improved localized pattern detection. And in convolution LSTM, it integrated convolution with LSTM, excelling at both spatial and temporal dependencies, delivering the best performance. So then the conclusion of the univariant was that the convolution LSTM emerged as the best performing model for univariant weather forecasting, which was a single column. So our milestone 3 was to implement the multivariant forecasting by incorporating multiple weather variables, improving accuracy significantly. So we used 2 different LSTM models for it. The first one was multiple input series, and the second one was multiple parallel series. So we processed the data by
Sorry to
multivariate
interrupt. Can you
inputs.
tell me what is the name of your project?
It was weather forecasting, like time wizard, by using LSTM models. So these were all the multivariate models which they captured additional context, significantly enhancing the forecasting accuracy. And in milestone 4, we focus on predicting multiple future timestamps and conduct comprehensive evaluation by using multi-step LSTM models. The models we used were vector output models and encode and decoder models. So we prepared the input-output pairs using sliding window techniques. We trained the model in various forecast horizons like 24 hours and 48 hours. And we compare all the models using MAE, MSE, and RMSE, and visualize all the graphs like actual versus predicted, and identify all the limitation and error. So the next part will be contributed by my teammate.
Okay, so now I will be discussing about challenges and the future scopes. So the first major problem that we faced were high computational cost. As we worked on with large data set and complex model, the computational resources needed for training were significant. This not only increased the time required, but also the cost associated with the
Can you
hardware.
show us the computational result? Please go to the next slide.
Sure, ma'am.
Because you're just speaking theory, na? We want results. Next slide.
Well, can you move to?
Yeah, these are the challenges and future scope. Okay, business proposition. Next one. Where are the graphs, analytics, conclusion, references? Okay, show us the
It
demo
will be
now.
shown with our other teammates. Yes, we will show it in the demo. Priyanshu, please share the demo.
Okay, so we have prepared the web app for presenting the GUI. So just I am sharing the screen.
Yeah.
So this is the multivariate LSTM model representation from the GUI. So we can see we have used a Streamlit library, where is an open source framework to rapidly build and share the machine learning web apps. So as we move to the multivariate, which is the extension of LSTM, designed to handle multiple input features for time series forecasting.
Okay.
So as we move. So first, we can drag and drop our data, which we want
please
to
do it
train.
fast. We will look into that data loading part.
Okay. So here I loaded the data. So it will get the stats and the data preview. Then I move to then we can
select
adjust
the model.
the
Please show us what all models you have incorporated. Drop down menu.
Yes. So this is the demo video. There are the options of vanilla, stacked model, and the bidirectional, conversational, and CNN.
I want to see.
Sorry, this is the demo video. I think I have recorded this previously.
But the thing is, today's final presentation, you have to recording video is not at all compatible, right? You should show us the live demo, right? This is what presentation is for.
After the demo video, we can show the.
No. I don't want demo video. Directly show us this video, what application which you have worked upon. I don't want recorded one and all. I will select the model training. You show me what I ask for. Yeah, go directly to the page. Where have you hosted this? Yeah.
Okay.
Go to the page. So I request all the interns to be very, practical. Tell us what you have worked on, methodology and implementation. Yes. Please share the screen.
Is it visible now?
Yeah. Go to the model training.
Yeah, actually, that my friend has generally used the univariate model for the training, but instead he has prepared a video. But I'm showing the like live model for the multivariate one. I'll show you like yeah. Here I've also used similarly the Streamlit one just for the interactive web application, but here I have like used the dataset, and I have to load the model since we have to choose from a variety of models. We do have like used at least 7 models for this LSTM, starting from the CNN to even the transformers. We have even used an hybrid LSTM model. But for since he has prepared on the univariate one, I have to do one on the multivariate one. So I've like loaded the multivariate file, and we have transformed it into an dot object file, and then we have tried to like host it deployed onto the local like yeah local web. So actually here you can see that since it had been preloaded, so we need not to like choose the model here. We can say like how many days we need to forecast. So it will depend on like
What
we
about
are
the other
currently
features? Yeah.
yeah, I'm coming to that. So we'll be like moving from 1 to like 15 days. I think LSTM would be enough for that. Otherwise, we have to move to the more advanced transformers model, and we'll be like choosing how many part of the like historical data we'll be using to
Yeah,
like
since you
predict the
used LSTM, correct?
yeah.
What is how do you capture the temporal dependencies?
For capturing the temporal dependency, like it's generally using through various models, like how's like for the temperature, we use all the like previous temperature values, like ranging from like since see the data set which was used was being recorded at like time interval of at least 10 minutes. So we need to, and for it was a period of 10 years. So it was around 4,20,000, I think, data
Correct. So one
elements. So
line, so the entire lines you can just put in one line. Since you're using LSTM model, na, so it
yeah,
has a memory cell that can store information over long period of time. That is your answer. Okay. So
yeah.
that is why how
Yeah,
by using LSTM you'll be capturing,
yeah.
temporal dependencies. Okay, fine. Then the next question is, see, since you're using LSTM, but there is a powerful forecasting tool available in the market. It's an open source tool available called as Profit. Did you come across this while working with your project?
Yeah, I
Yeah,
did have heard about the
Profit. How do
profit
you
model,
pronounce?
but we were
Ah,
asked to like focus more on the like this only, this
correct.
LSTM model. I even tried to see. I even tried to. This is the multi-step model. We have tried 7 models as I have said. So this was the I think fifth one. This was the stacked model, and then what it is also a stacked model, which we generally be playing around with the parameters. But
Correct.
then I just as you said that it was profit. So I did come across with another model which was transformer LSTM hybrid. I thought to like go a little beyond about the LSTM model. So I tried to use this
Actually,
only.
combining Profit and LSTM, a hybrid model works fine for forecasting model. Yeah, thank you so much, team. We took a lot of time.
Yeah.
So, Meenakshi, shall we go with the next project?
Okay. Thank you, ma'am.
Yeah, I just have one question. Like, from where you have collected this data? Like, what was your source?
Ma'am,
Ma'am, it
this
was TensorFlow.
TensorFlow dataset.
Okay.
Data set. TensorFlow is a
Data set, where did you
No,
collect?
the dataset, it is from the TensorFlow Keras dataset repository. It is a single
Okay.
repository which is equal to UCI.
Yeah.
Okay.
So, just like Meenakshi, it's just like UCI repository now for machine learning data set, they are taking
Yeah.
from that data set.
Yeah, there are multiple dataset like
Yeah.
repository nowadays have
Yes,
come. So we came across with this one because the dataset was vast, so we need to do a lot of pre-processing work also.
Yeah,
So we
I
found
understand.
this one
Yeah.
suitable for
Thank
it.
you. Yeah. So, next project, advanced image recognition for next era. Please load the PPT. Yeah. Thank you, all the interns.
Thank you, ma'am.
Good job. Yeah.
Okay,
you.
thank you.
Thank you, ma'am.
Thank you, ma'am.
Please load the PPT. Yeah, start the presentation. Am I audible? Yeah. Please start the presentation. Yes. Yeah, you first of all, you're not audible. The one who is sharing, Sudarshan, who is explaining. Spandan, please just look into why they are delaying things.
Yeah, exactly. I think your voice is not audible, whatever you're presenting.
Are they presenting?
Yeah, Thota Saichand, you're trying to say something.
Hello, ma'am.
Yeah, who is talking here?
My friend is not responding, so I will continue. Sudarshan, share the PPT. Yeah. This is a advanced visionary advanced image recognition projects. Basically, we have collected 10 classes image. We have taken particular celebrities like cricketers. Each image class we have collected 250 images from. We have taken some images from Kaggle, and some we have manually downloaded, and we have collected our database. We of 10 classes, each class contain 250 images. Next slide. Sorry for our interrupt. Again, we have done data pre-processing like grayscale resizing, normalization, and some age detection. So yeah, we have. Hello, ma'am. So we have done our pre-processing. Again, change. Again, we have done data augmentation. Like we have added done some rotation, flipping, cropping. So we have a number of images will be increasing. So it will be help for training, validation, testing. So we have some uses. Again, we have stored that images in for in another folder for training, and we will split that into trace validation. Change.
Can we directly go to the architecture and methodology part? Yeah.
Like we will, like ma'am, we will show demo. Like we have
building CNN model. Okay, next slide.
Yeah. Change.
Yeah, please explain from here. Yeah.
Like Tushar.
Ma'am, our initial model was CNN, ma'am. And next, in that model, we faced the challenges like overfitting we faced, ma'am. So that we incorporated transfer learning. So it is a technique that leverages pre-trained models for new tasks. So by using this transfer learning, it allowed us to use a VGG16, a model pre-trained on a large data set. So as a base of for our project, we fine-tuned specific layers of VG16. Then this approach significantly improved accuracy, reduced overfitting, and helped us to extract the features, ma'am. So the result was a model that could generate effectively to unseen data. So by addressing the overfitting challenge, we ensured that model performed consistently across various data sets. So once our model was trained, we evaluated its performances to ensure its robustness. Change to next slide. Yeah, while coming to model evaluation, we evaluated the model using metrics such as accuracy, precision, and loss. So the accuracy and loss graph show steady improvement so that we confirmed the model's learning ability. And next, to validate the model's robustness, we tested it on unseen data, and then the results demonstrated high precision, proving its effectiveness in identifying celebrities beyond the training set. Overall, transfer learning played a pivotal role in overcoming the challenges, enabling us to build a reliable and high performing model, ma'am. Now, with the model successfully trained and evaluated, the next step was deploying it into a user friendly interface for real world use. Tushar will now talk you through the deployment process.
Yes, hello everyone. We deployed our model as the Streamlit. This is our user interface. This contains the upload and image part and list of the cricket players recognized by the model, where we selected from the dataset. Next part. The Dockerization part, firstly we created the file structure. Next, we created the Docker file. It contains some commands how to build like the Docker file and what libraries got. Then we install the Docker into the system, where the images by running the command, and it will be take something the cloud options. Next. This is a model testing, and we will be testing the model by the on the user interface, like detecting the face of the cricketer, and in the real time, having the model prediction confidence with, and which cricketer is predicted correctly. Next. This is a results and conclusion, where the plot graph shows the accuracy gains and high precision with the model accuracy and model loss with the transfer learning, and the final model achieves the high precision on the test data. Thank you.
Okay, are you showing us the demo part?
Yes, hello everyone. Am I audible?
Yeah.
Okay, is my screen visible, ma'am?
Yes.
Okay, good evening everyone. Now we will move on to our demo of this project. This is okay. So this is our the simple user interface made by Streamlit. So here we can see that this is an responsive page, and here these are firstly these are the list of cricketers which are recognized by this model, because we can't use each cricketer from the world due to the computational constraints. So first of all, this model works with this image uploader. Like we can upload any cricketer from the web. These images are not trained before on this model. These are taken from the web. Like there is a Virat Kohli image, we can upload it here, and now we can see that this model predicted correctly that this image is Virat Kohli's image, and this is the confidence it is showing that this Virat Kohli image is 92.74%. Like model is predictingly very correctly. We can see any take any image, other image, like here
Yeah,
it is the
we shall go
Steve
with
Smith image.
This is what your
Okay, so
project does. Any more features you have implemented other than the model prediction? Yeah.
no, ma'am. Until now, it is only the model prediction. But for the future scopes, we can increase the number of classes, like for the number of cricketers, and we can also increase. Implement Git by the help of GitHub Actions the real-time pipeline, so that if anyone, any user upload a new image, so that our model trained on that image automatically.
Okay. What are the key takeaways of your project, Priyanshu?
Ma- Yes, ma'am. So, take away, first of all, the major challenge that we have faced in this project is that the limitation of the data, and so the basic structure of the CNN model from scratch cannot predict the correct images from the small size of data. So the first takeaway we get, transfer learning is very efficient for the small data sets, because the pre-trained models are efficient for detecting the edges which are important for any image, and also the data augmentation part for the image, increasing of the image data set.
Okay. So why I asked you, because is, yeah, see, there are, your project is like this is the latest of the AI, wherein, we do have different types of trained data. So whether your project works on only supervised or unsupervised images.
That what do you mean by supervised and supervised images?
Obviously, using image, we are working with image, right? So can you just
Yes,
tell us,
ma'am.
are you using supervised?
Ma'am, I don't get that. What is supervised?
What is
Ma'am,
supervised learning and
Ma'am, we
unsupervised?
have you.
ma'am, actually is
Yes, ma'am. It is a
working on train data on test data also. Like we have upload a new image, it will work.
Meenakshi, do you have any questions? Please do ask them.
No, I don't have any question. Actually, frankly speaking, I couldn't understand everything properly. Like I
Okay.
can ask you some technical questions, but first, what is the objective of your project? That is not clear to me.
Ma'am, main
Like
objective of this project is to identify an unrecognized image by uploading an image, and it will identify the person, whoever the image is
Can
belonging
you
to.
show me again how you are doing this?
Ma'am, demo?
Yes.
Okay, ma'am. So here it is the user interface. So there is a image uploader. Uh, in that, by the help of this uploader, we can upload any image, uh, and we can get the information that who the images belongs to. Like here I have uploaded the Trent Bolt image, and here it is showing that the predicted cricketer is Trent Bolt, and the confidence that model is confident by 83% that who the image belongs to. So how it is working?
Have you tried it on the real images? Like these are the training images. After that, have you tried with other images?
No, ma'am. These are not trained images. I have downloaded this from web. I can show you live also. I can show you. We can upload any image to this model. Like I can download this image from the web and save it to my directory. And now I can go to this uploader and uh, I think that image was not saved. Okay, we will try once more.
Fine. Yeah. Thank you so much. Meenakshi, shall we go with the next one?
Yeah, it's fine. It's fine.
Yeah. Thank you, interns. Yes. So I request
Okay,
the
ma'am.
next project, unmasking fake news for a more informed world. Please, start with the presentation.
Hello, ma'am.
Hello, ma'am. Ma'am,
Yes, you are audible.
ma'am, can we present, ma'am? Our demo is ready to show to present that video.
It's not PPT, it's a PDF.
Hello, ma'am.
Can you hear us, ma'am?
Yes.
Yes. So,
You can start with the presentation.
You can directly explain what your project is doing, what technology you have used.
A very good evening, everyone. Here is our project AI Truth Seeker aimed at combating misinformation using machine learning and deep learning techniques. So, the goal of this project was to build a reliable system to help differentiate between real and fake news, contributing to a more informed digital world. Let's now explore the approach and the results we have achieved. We began by consolidating various data sets into a comprehensive data set to increase the diversity of our training data. Next, we cleaned the data by handling missing values and addressing class imbalances. We also identified key patterns and related to text lengths and token frequencies that would influence our model's performance. And as we examined the label distribution, the final data set consisted of 63,700 real news articles and 59,600 fake news articles. For text pre-processing, we applied several techniques, including lowercasing, punctuation removal, tokenization, stop word removal, lemmatization, and POS tagging. And here's a visual representation of the data set before and after pre-processing. So on the left, First column contains the raw text, while the adjacent column showcases the cleaned and standardized version of the text. And with pre-processing complete, we began model training using a multinomial naive Bayes, a simple yet effective choice for text classification. To optimize performance, we fine-tuned the alpha parameter using both grid search CV and randomized search CV. Here's the classification report showing the performance of the model across various metrics. The model achieved over 88.35% accuracy. Then we fine-tune the model's hyperparameters by optimizing the alpha parameter for better performance, which resulted in 89.99% accuracy. We then implemented the random forest classifier, a more robust ensemble model. By tuning the hyperparameters, we achieved an impressive result of 97.6% accuracy on the training data and 94.9% accuracy on the test data. So as we can see from the classification report, this model provided a balanced approach with good precision and recall. Next, let's look at the implementation of deep learning models.
Now I'll walk you through our deep learning models implementation for fake news detection, where we explored multiple neural architectures with impressive results. So starting with RNN using gated recurrent units, we implemented batch normalization and early stopping to optimize training stability. So this approach achieved an accuracy of 97.57%, demonstrating excellent capability in capturing sequential text patterns. And here you can see the results of batch normalization and early normalization. And now our bidirectional LSTM model. Bidirectional LSTM model proved particularly effective by analyzing text in both forward and backward direction, reaching 97.42% accuracy. So this bidirectional processing enables superior context understanding, especially crucial for detecting subtle nuances in news articles. And the CNN architecture, we developed incorporated embedding layers for semantic word representation, followed by convolutional and pooling layers for pattern detection. So this model achieved 96.20% accuracy, showing particular strength in identifying local text patterns efficiently. And our transformer-based approaches using Robota yielded our most sophisticated results. The small digital Robota-based model achieved 97.14% accuracy, while maintaining the computational efficiency. A larger Robota model, though slightly lower at 96.33% accuracy, demonstrated superior handling of complex cases. And the real-world testing have been particularly encouraging. When we tested our system with various news articles, it demonstrated excellent accuracy in both directions. So it successfully identified the fake news articles as fake and then correctly classified legitimate news articles as true. So this balanced performance in both fake and true news detections validates the robustness of our approach. It shows that our system isn't just capable of spotting fake news, but can also reliably verify legitimate news sources. And to summarize our findings, the RNN with GRU provided solid base performance. Bidirectional LSTM variant excelled at different aspects of text processing. CNN offered efficient pattern recognition. Transformer models demonstrated superior handling of complex cases, and then real-world testing confirmed accurate classification of both fake and true news. And each approach has its strength, and together they provide a comprehensive toolkit for detecting fake news with options suitable for different computational resources and accuracy needs. Thank you for your attention, and now on to the demo team.
Ma'am, can I share this screen?
Yeah, please go on. Yeah.
Okay. Ma'am, is it visible?
Yeah.
So, like, as presentation team has done all the things, so can I check with a news article because the
Yes,
things
yes,
like
yes. Please go
importing the
on.
libraries. Yes. Okay.
See, like just now I have run this. So model naive bias have showing it as fake news as fake news. This is the correct prediction I am getting from the naive multinomial naive bias, which got the accuracy like 87.8, and from the this one also like hyperparameter tuning, I have got news article and real news as real news in the correct prediction. So this for multinomial naive Bayes hyperparameter tuning. I have done this part. Then I have got the accuracy of in random forest classifier like 91.21. So I have tested with this also news article and showing me this
Okay.
real news as real
Now,
news,
who
and
is
going up to
speaking?
the this is machine learning part.
Subhanshu, right? Subhanshu, sorry
Ma'am,
for
me, Shubham.
interrupting.
Yes,
Okay.
ma'am. Yes,
For
ma'am.
fake and real news data set. So how many models are actually you're considering in your project?
Like ma'am, machine learning 2 models, from deep learning 2 models, and from the transformers 2 models.
Okay. Yeah. Please continue. Huh.
So like this is the machine learning part. Then going up to the RNN side. In RNN side, I have tested and also got this
Hmm. Okay. In each type
correct
of
prediction.
particular
I
model,
will show the transformer models.
what are the techniques you have incorporated
Yeah,
in
I
the
will go up to the So ma'am, like in RNN with GRU, I have implemented like graded neural network. So in this, I have pre-processed and the sequence length I have find out. And yeah, I have find out this one like bidirectional GRU I have implemented. And with bidirectional GRU, I have like 10% dropout. And with that, I have predicted the mod and got the accuracy of like 97.9%. And when I have checked with it, I got the real news at real news. And going up to the transformer part, in transformer part I have implemented the small robota, and it's like first of all I have to check the GPU is available or not. So I have checked the GPU, then I have trained because it causes some problem when training with normal CPU. So from this, I have trained my small robota with PyTorch and getting up to the accuracy of 97.14%. And this also I am getting like I have loaded the tensors. So this one I have checked with it, and it is also getting the actual level as predicted level, the correct prediction from the transfer model.
What are the findings of your project according to the techniques? Have you just listed out what are the findings according to your outcome?
Like ma'am, this outcome is what, like if anyone is having some fake news, so like I have implemented from a particular data set, but like if the news is someone don't know about the news that is fake or not, so they can test with our source that this is a fake news or this is a real.
Correct.
That is our project
That is the
finding that.
what do we call it as preliminary feature of your project. Other than that, did you not
Yes,
find?
ma'am.
What are the findings of your project then?
Like ma'am, transformers is the another finding. Like transformer from small robot type, we have implemented the small BERT model. So from BERT model, it is showing me the correct accuracy because it's a transformer model, and we are loading the transformer model in our part. So we are getting that, and
Okay,
it
I'll tell you.
requires a high
So
accelerated GPU.
So please listen. So the project which you're working on is like we do have n number of models. Researchers have used n number of models. So the models mainly deals with the techniques can be you have used LSTM or learning models or Keras neural networks, graph-based semantic structures, CNN. There are n number of models
Yes,
are applicable, and there are n number of research papers also available. Now, what are the findings? Is
also.
for example, say first is model efficiency, correct? So when you
Yeah, yeah, ma'am.
what is the model efficiency? That will definitely
So
impact
like
the choice of features and classifiers. That you have to tell in the project.
Ma'am,
Okay. Have you come up with the
ma'am,
efficiency?
ma'am, so through the Truth Seeker project, we explored the potential of machine learning and deep learning to combat misinformation. So
Okay.
we tested multiple models from simple multinomial naive-Bayes to advanced transformers like Robota. And while simpler models were fast and efficient, transform models, especially the small Robota, deliver the highest accuracy of
Highest accuracy.
97.25%. So balancing
Another question
performance
is,
and
for
resource
example,
efficiency.
say I have a one piece of data, okay, that hasn't been fully used for fake news identification by using what neural based patterns of news propagations. So therefore, we recommend, by taking a transmission into account when identify the bogus news. So how do you find out?
So, ma'am, like I will do first the NLTK, like NLTK techniques, like NLP pre-processing. I will do, because if bogus data is there, so something is there in the data which is not good. So first of all, we have to clean the
What
data.
about the noise? You're not talking about the noise, na? I'm just waiting for that answer
I
from
don't
your
think they
end.
have implemented the video and audio news analysis.
No,
Like
no,
They
no.
have done
video
for
or
the only
ma'am,
text
this
and
is a
news, right?
text classification. Yes, ma'am. Yes, ma'am. This is
Yeah.
only the NLP based text
Even in the
classification,
text,
not
we
the
do have a
news.
noise. Correct. Even if, for example,
Yeah, yeah, that news and
Ah,
like noise is there and something is there. I have cleaned in the cleaning part, like I have done with the cleaning part. This part. 1 second.
you.